So hopefully I've given you a good idea of the background of the industry. So now let's look at what are the opportunities. I've given you some hints to some of this, but let's see what we come up with. One question I have though, since you folks are not asking any questions, I'm running right through. If I have time at the end, I might call on maybe one or two people that might have a startup idea, and we can walk you through the thought process of how to think about whether this is feasible or not. So are there any volunteers who might want to share an idea? Anybody want to get free advice? Nobody thought of a startup? Well, think about it. I know the HKUST team might have one. So let me see if I can get some time here at the end, and we'll talk some more, okay? So, you know, as a designer, you know, as a semiconductor person, if you look at a device like a phone, what are the things that really matter? It really matters from a system perspective what the user experience is, right? You got to build something that the user will really like. You don't want to get it too hot, right? That's the user experience. You want to make it easier for them, you know, whether it's a touch screen or whatever. They all care about performance. We all, when we go buy a device, laptop, smartphone, whatever, it's got to be better than the previous generation by 30%, right? That happens over and over again. It has to be compact. One exception though, in smartphones, we're looking for larger screens, right? So we want it thinner, but that's one area where the compactness can be violated because of the size of the screen. But in general, most things have to be compact. Combination of these three is pretty bulky, right? So if you can make it compact, that form factor can be a very important driver for a potential new product. Cost is very important, and power or battery life or energy are very important. So these are four key factors. User experience happens in every case. So if you're a semiconductor engineer, you always have to worry about cost, performance, form factor, and power. So over the years, how have we done this? Is more and more, right? Reduce scaling to get your reduced cost. You do more than more, which is able to stack devices, do things in three-dimensional. I'll give you some examples of what that is. You can use stacking. You can stack a couple different chips. You can do TSV, is through silicon vias. You can do flip chip and TSVs. You can do MEMS. Who knows what a MEMS is? Micro electromechanical systems. So all kinds of things like that, which are part of the more than more scenario. And then the third thing that most people don't talk about is integrating architecture and software and design together. I gave you one example of where you put the processor to sleep. That's a co-design integration of all three items. So in a simplified manner, if you look at the big picture, I've seen this in the last 40 plus years of my career. I used to work at a system company where the vice president of the system group says, I don't care about your technology stuff, just give me my performance and cost and functionality. I don't care how you make it. And that is true to a large extent about a lot of system people. They don't really care how you do it. It's just got to work. And it's got to work reliably. So from a semiconductor perspective, what we boil it down into is I got to do more advanced technology, I got to do more packaging innovation, and I got to figure out some ways to combine architecture and design. So that's kind of an overall picture in the context of the smartphone. Guess what? Same thing applies for a laptop. So laptops are getting thinner, lighter, solid-state drive, all kinds of things, very similar kind of situation. user experience, performance, cost, low cost, power, and using these techniques. So kind of an overall chart that has helped me in good stead describing what is it that we're doing in this business. Any questions, comments? You take a device like a smartphone, everybody wants to put more features on it. We as users demand it, and the competition in each of these areas, each of these providers wants to build more functionality because that's what people will buy, right? Now, how they decide what functionality to build in is a combination of what you're capable of doing, but you should also listen to your customer. If you keep providing, you know, more and more memory on there, and customer really doesn't care about it, they're not willing to pay extra for it. So you got to be careful whether you're a big company or a small company, what features you want to add in there. So what are some of the opportunities? If you look at the smartphone, as I mentioned to you, in there is a motherboard that is loaded with components. The Apple, in this case, is the A6 processor. Today is what, the A9, I think, and the i7s going to A10. There's a Qualcomm chipset. I think that's the modem, and that's probably the transceiver in there. There's a Broadcom chip, a TI chip, and a bunch of other support chips. And like I mentioned, and they're loaded on both sides. So they all have to work with Ultrabook or latest PCs. Same kinds of situation apply. Integration of disciplines is extremely important. Software has to work with the display, the antenna, the touch screen, the processor, you name it. They all have to work together. And like I said earlier, somebody has got to make it happen. Some engineer at Apple or Qualcomm or TI, whoever the supplier is working their tail off trying to simulate it, trying to make sure everything works. From a design perspective, from a process perspective, from a packaging perspective, from reliability, because you don't want your phone to die in 30 days, right? And it has to work the first day. It doesn't have to die the first, doesn't have to. If it dies, you get really mad as a user, right? So all these things that we take for granted, somebody has to make happen, and that somebody could be you. Co-design is an extremely important thing, because if you look at historically, us engineers tend to be very narrow into our focus area. If I'm a process engineer, in general, I'll stick with my process engineering. I'm not going to go talk to a designer. That's the way it used to be. Today, you can't really get by without having to talk to other people. And so what I've tried to show pictorially, a successful company really should try to integrate all these activities. Silicon folks have to be talking to the packaging guys and the test people and the designers and bringing the most leverage together. I started this 35, 40 years ago. Remember I told you I was an ion plant engineer, built devices. Once the devices were built, I wanted to see what the result was in the package. And then the first time I did this as a program manager, there was no package. We busted our buns in the wafer fab to get the silicon out, and then it sat and waited because there was no package for it. That's just not good engineering discipline. So that's what made me motivated to work on cooperative activities where if I was starting a new program, we would bring all the people together, all the different disciplines, plan out what your plan was going to be, and make sure everybody knew they were going to do their piece in order to get the device out the door. So that's a nutshell of co-design. And here's an example. I don't know if you can read the chart in the back, but by the way, not all my charts are here. I have inserted some new charts. So I don't know if this is a new one or not, but I just went to a IMEC is the largest R&D facility in the world. Professor Kleiss was at IMEC until recently when he retired. But they have a technology forum in the United States a couple weeks ago. So they presented this chart that showed, again, Moore's law and how you can get increased number of transistors in the different technologies. But they're talking about in this time frame, the 14 nanometer FinFET, you really have to have DTCO. DTCO is design technology co-optimization. That means the process and design people have to work together, not only to make sure what features are working together, but how you set up the design rules so that you get the most number of routing tracks, for instance, to get the maximum density, of packing density. Those things, ideally, in the past used to be designer, process guy will set the design rule manual, and the designers would set up their track rules, how many tracks there are possible. I think the Synopsys gentleman will probably get into more of that, how you lay out the libraries. But this is an example where by changing slight dimensions in the design rules, you can get much better packing density. So that would be the co-optimization. System technology co-optimization could be similar examples where you can, depending on the constraints, the system designer can get much better either access to lower the leakage or model the leakage or something like that, right? So that's what they're saying in the continuum here. What they're saying is that they call this the happy scaling up until maybe the 28 nanometer. Then you get into less happy scaling, and then you need co-optimization, and then you need a system technology optimization. So this is a different picture than what we talked about before as to the Moore's law being flattening out. So they're showing maybe a little bit of flattening here, but they're also saying that there's a continuum all the way up to 3.5, 2.5 nanometer technology. So I don't think this is going away anytime soon. This is going to be around. The technology is going to be there. It offers all kinds of challenging opportunities for designers, for process people, for packaging people to be working together and coming up with solutions. So that's kind of the core of, remember I said the opening statement, if I was starting over, I wouldn't mind getting into the middle of this, right? Because I like to do things that are multidisciplinary. Not everybody does. And so that instantly gives me an advantage to be looking at that. Now, I happen to have the experience in many different areas, and you may not, so you got to work towards that. It's not going to happen on day one, but certainly keep your minds towards that direction. I will show a similar chart in the summary here, but it's a scale-down device, which is sort of a linear scaling. Remember, we talked 0.7x every time, new generation. And here is more of a area scaling, and then this is more of a system level scaling. So there's a path that people have been thinking about, and I think it's going to happen. Here's an example again of co-optimization where this is an example again from IMEC that they were giving about a gentleman that had his arm amputated for whatever reason, didn't have his arm, so they had a prosthetic arm, and then they created this sensor, a chip that gets implanted into the arm where it was terminated, and it connects to the brain and helps the gentleman drive his fingers based on what his brain is thinking. That takes a lot of cooperative design between biomedical people, electronics engineers, packaging engineers, chip designers, all working together to get this implant to work. Is that exciting or what? I think that's phenomenal. So if you're an analog designer, I imagine this is an analog set of inputs. They probably have to digitize, connect to the brain, provide some commands. I don't know what the content of the chip is, but the whole concept seems extremely exciting to me. It's on a flexible substrate. It's got to be reliable. Doesn't die just because they were washing something or it gets wet. So reliability is an important consideration. Packaging is an important consideration. Circuit design, and the system level. tremendous opportunity. Oops. Another input from IMEC. The CEO was providing the input that said he believes that the technology is going to play a continuing role in the future going forward. And he's giving me some examples of where technology is going to be really key. Endless increase in complexity, we saw that, right? Moore's law keeps going up, more transistors, more functionality, more performance, managing leakage, all of those things. There's lots of activity from artificial intelligence, machine learning. We talked about DeFi this morning, about the deep learning. It's a Chinese company that's looking at recognizing images from a drone based on deep learning. Pretty important stuff, right? Drones are pretty important. If you have an algorithm that does that and you put it in a product, you can get rich, right? So what he's saying is that artificial intelligence is going to define how chips operate, how the architecture is there. They're doing a lot of work on neuromorphic computing, quantum computing. There's all kinds of new stuff that's going on. So don't ever believe that there isn't technology that you could participate in. You could do today's chips, you could do tomorrow's chips, or you could do the day after tomorrow's chips, right? You could, depending on where you are. If you stay in the research field, I would get into some of these activities and get more intense, write the papers and publications for it. And I would also want to get reach out against across functional boundaries. Get involved with the medical school. I think Professor Vanderspiegel talked about brain-machine interface, right? So there's cooperation between the medical school and the electronics school. I know at my university there's all kinds of activity going on between social sciences, between healthy aging, lots of people-related problems that then get back into creating solutions. So I was going to bring that up in the startup thing also, right? We have a design competition for seniors in electrical engineering and computer science and cognitive science, all working together to come up with solutions for aged people. I'm sure in China also there's population is getting older, and there's a lot of support that they need. So what we teach those people is to go observe the seniors and see what their problem is. Because if you walk up to them and say, "What do you need?" They say, "I don't know." One example on that, since I started talking about it, is there's a methodology called human-centered design. And what you do is you sit down with a senior. So if you're a senior and you got a hearing aid and all of a sudden your hearing aid doesn't work, so you're taking this hearing aid out and your hand's shaking and you're trying to change this little tiny battery, that's a problem, right? If you have a solution, you might want to consider that as a possible startup. So maybe an automatic way to replace the battery in a hearing aid. Is that super sexy, exciting, double E stuff? Probably not. But if it's a solution that the customer is willing to pay you $10 for, and it costs you $1 to make, you can make $9 a part. Huge business. So that's the kind of mentality that you have to get into, okay? Anyway, I don't know how I got into it, but so this is the technologically, lots of advances coming, and they seem to be never ending. Now, interestingly, there's fewer and fewer research institutions like IMEC that do this kind of work anymore. It used to be Bell Labs, it used to be IBM. IMEC is now the primary one, and so get involved. I don't know what's in China. I think there's probably more of the R&D centers. The universities. But if that's your bailiwick, get involved, find out where it's happening, and get involved there. From a product development perspective, this is something I saw from Intel showed this in Shenzhen last year at their IDF, Intel Development Forum, is a compact desktop. It's no longer the big box that sits on the floor. This is something that's modular. It has a little base unit, a little hard disk drive, an audio unit, and a charger unit, and you can mix and match whatever you want. And the whole thing fits on your desktop. Now, Intel is going to do that innovation, so don't go do a startup that competes with Intel to make that startup unit. That's not a good startup idea, right? But just to give you an idea, you could go work for Intel and work in one of these departments and do the circuit design that goes into the audio chips. That's perfectly okay. And while you're doing that, you learn how they run the business. And if you have the passion to be doing the startup in 5, 10 years, learn all the things you can learn while you're working at Intel, and then go do your startup when the time comes. Okay, so that's a perfectly okay career path. These companies, of course, you know, they're big companies. They have a lot of resources. They can invest in it. They can do the marketing research to go figure out what people really need. And they also want to keep growing, right? So here's an example of Qualcomm. Again, last year they had an analyst day. So they are big in SoCs, right? System and chips that go into the phone. But they are also looking at adjacent areas. They're saying, what can you do with this kind of a chip? In fact, if you think about it, Apple iWatch, for instance, right? That connects to the phone, but it's not a standalone device. It needs the iPhone to be able to receive messages. So I know that Qualcomm's working with Michael Kors to develop a watch, which is a standalone watch built on the Snapdragon. That's a standalone that you don't need the phone, and it'll answer your phone calls. So, and it looks like Michael Kors will put in the design. So, you know, the iWatch is kind of squarish, yeah, sleek, but it's still a boxy little thing, right? So what Michael Kors is going to do is they're going to take that base chip, make it standalone, and they're going to make it look like a conventional high-end watch. Now, they better do the research to make sure customers really care about it, and customers will buy it. But intuitively, it sounds like a neat idea, right? And it's totally different. So they are looking to expand. The reason I brought it up is Qualcomm is looking to expand their market reach, not just into smartphones. Smartphones is the base. They want to get into wearables, smartphones, smart cities, robotics, mobile computing, networking, automotive. I mean, the whole space is getting very fuzzy. Intel's getting into mobile. Qualcomm's getting into computing. It's all kind of getting fuzzy together, right? But all that creates opportunities for the big companies. And as they create the demand, maybe there'll be demand for startups. And that's what you got to keep your eyes open for. Here's an example how you could use the Snapdragon in a drone. So what they're saying is that if somebody were to make a drone, they have to have all these different PC boards, and the total area of the board is about 190 square centimeters. If you use the Snapdragon reference board, it's only 23. So there's a significant form factor reduction. Get used to that term, form factor. It's the size. It's the height, width, length, right? And that gets much smaller. So is that important for a drone? Absolutely, because this stuff weighs, doesn't tell me the weight here, but the size matters because that can determine how far the drone can go on its own. A lot of innovation opportunities in drones themselves, right? So if you have a neat way to do something that nobody else can, maybe that's a startup opportunity, right? Now, this whole area of Internet of Things and 5G is also very exciting because I'm not a 5G expert, but I think what you're really doing is the 50 billion devices of Internet of Things, Internet of everything, that really has to build in smart objects everywhere. And these will likely talk to a phone, which talks to a network, which goes to a cloud, and lots of data that has to be processed. So there's, again, increasing demand for semiconductors, but also creates all kinds of opportunities, right? So you could be a startup and you could think of, well, you know, this doesn't show an electric kettle in my room, right? I mean, there's all kinds of things that you could conceivably think of that solve a problem that makes it easy. I mean, this is a really nice hotel. I don't know if any of you are staying here, but what an entrepreneur does is you're constantly looking at what is the problem. I have a problem trying to find the right lights. Maybe there's an automatic app that you can write, or there's a gadget that they can provide that makes it easier for you to figure out which light needs to turn on and all that stuff. So a startup, you know, if you look around the room, somebody created solutions, whether they created them and had their company market it, or the startup marketed it themselves, can depend, right? And so you just have to be thinking about what ideas are there, what problems are you really solving. Anyway, lots of opportunities in IoT and 5G. Security becomes a big concern. With 5G, by the way, it's not just about, I'm getting ahead, I'll come up. So let me just run through here. In the automobiles, automatic, you know, the ADAS system, the self